Air density. Density is defined as mass per unit volume and may be expressed as grams or kilograms per cubic metre. Percentage of the standard surface density, relative density. Altitude in the standard atmosphere to which the observed density corresponds to is density altitude. The density of the air in the international standard atmosphere is 1.225 kilograms per cubic metre. Density decreases with altitude. Low density will reduce lift, increase the takeoff run, and reduce maximum takeoff mass. The effect of temperature and pressure on air density. A decrease in temperature increases density, and an increase in temperature decreases density. A decrease in pressure decreases density, and an increase in pressure increases density. The effect of pressure decrease with height is greater than the effect of temperature decrease with height. Therefore, density overall decreases with height. The density at the surface will be low when the pressure is low and the temperature is high. Temperature. Temperature is measured using three scales: Fahrenheit, 32 to 212 degrees, Celsius, 0 degrees to 100 degrees, and Kelvin, 273 degrees to 373 degrees. Obviously, there are values outside these ranges. The assumed isotemperature at sea level is plus 15 degrees Celsius. Measuring air temperature. This is done typically in a Stephenson screen. The standard means of measurement on the ground is a mercury thermometer placed in the Stephenson screen. The height of the box is approximately 4 feet above ground level, 1.25 meters. Within it is a dry bulb thermometer to measure outside air temperature and a wet bulb thermometer, which may be used to calculate dew point. Atmospheric heating. The atmosphere is heated by sun's shortwave in. Surface heating by solar radiation is called insolation. Terrestrial radiation is 21%. This is the Earth's radiating heat long wave. Air is heated from below and decreases in temperature with height, creating a lapse rate. Conduction is 7%. Air in contact with the surface will be heated by conduction. Convection is 23%. Air heated by conduction will become less dense and will rise as thermals. Condensation. Air that has become less dense and has risen as thermals will be cooled adiabatically, and gaseous water vapour will condense. This in itself results in the release of heat. The sun is at its highest elevation at 12 o'clock local. The temperature is at its greatest at 1400 local. Temperature is at its least just after dawn. The effects of cloud cover. By day, solar radiation is reflected by the cloud tops back up, hence the surface temperature decreases. At night, terrestrial radiation is kept in if there is a cloud blanket and surface temperature increases. The effects of wind. By day, mixing of warm air below with the cool air above results in a cooler surface temperature. At night, an inversion above the surface causes cold air below to mix with warm air above, and the surface temperature increases. Land has low specific heat. The sea has high specific heat. An island has higher specific heat than mainland. Grass has a higher specific heat than concrete. Latent heat changes. As a solid changes state to a liquid, this is called melting, and 800 calories per gram of energy is absorbed. As a liquid changes state to a gas, this is called vaporization, and 540 calories per gram is absorbed. As a gas changes state back to a liquid, this is called condensation, and 540 calories per gram is released. As a liquid changes state to a solid, 80 calories per gram of heat is released in a freezing process. A change in state from solid to gas with no sign of the intervening state is called sublimation. This is a reversible process. It's also known as sublimation, or more correctly as deposition, from a gas going straight back to a solid.